I'm going to talk a little bit about binomial theorem. Okay, here before that, I'd like to introduce this so-called Pascal's triangle, because Pascal is a mathematician. Okay, if you want to know more about Pascal, you may Google and search about him. Okay, so over here we call this Pascal's triangle, and then the first one is 1, and the second one is just, you look at this, uh, the outer is all 1, okay, always 1, and then you put it arranged in the form of triangle. So over here the next one is 1 1, and then 1 2 1. How to get 1 2 1? Okay, 1 plus 1 is 2. Okay, and the next one is still put 1, and then 1 plus 2 is 3. 1 plus 2 is 3. And then over here, by the side is 1. Okay, always put 1 by the side. And then this one, 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Okay, and then by the side is still 1. So called the head and the tail. Okay, the two sides are all 1. Okay, and if you look at this, the expansion of x plus y to the power 0. Okay, we know that anything to the power 0 is 1. Okay, and then x plus y to the power 1, when you expand it, it's still x plus y. This is still the same, x plus y. Okay, and then x plus y to the power 2, this will be x squared plus 2xy plus y squared. Okay, so this is how we got 1 2 1. 1 2 1. There's nothing means 1. Okay, so we can look at, I've done some example here. 0 is 1. Okay, anything the power 0 is 1. And then 1, of course, it will remain the same. And then power 2, 1 2 1. 1 2 1. Power 3, 1 3 3 1. Look at this, 1 3 3 1. Okay, and power 4, 1 4 6 4 1. 1 4 6 4 1. Look at here, 1 4 6 4 1. Okay, and then how to assign the power? The power, you look at this power, the first one will be in, the first term will be in descending order. Okay, the power is in descending order, 2 1, and then the next one will be power 0. Power 0 will be 1, and then y will be power 0, power 1, power 2. Same for this. Okay, power 3 2 1 0, and the y will be start from y power 0. Okay, power 1, power, anything the power 0 is 1. That's why we don't put a power 0 here. Power 0, power 1, power 2, power 3. Okay, and then same for the next one, 4 3 2 1 for the x's, and then the y will be 0 1 2 3 4. So one term is in descending order, the other term is in ascending order. So this is how so-called a shortcut to do the expansion. But of course, if the power is too large, then it will be very time consuming to use this Pascal's triangle method to get the power. This is why we have binomial theorem. Okay, this is so-called the binomial theorem to expand for the higher power. Okay. So it doesn't matter whether it's x first or y first, it's just a letter. You can put x here, y or x, y first and x, it doesn't matter. So long as the first term is in descending order, the power. The second term here is in ascending order. Okay, so, and we always come across that we so-called t, the term r plus 1 term. Why call r plus 1 term? Of course, it can, some people also say put a k plus 1 term. Okay, it doesn't matter whether it's R or K, it's just a letter. If you are not happy with K, you can use R or you can use other letter. Okay, so why R plus one term? Okay, if the n is 0, R plus 1 is 1. So there's always one term. Okay, you look at this one. If the n, I think look at this one, it's easier. If the n is 0, you have only one term, 1 term. If the n is 1, you have two term, 1, 2. If the n is 2, you have three terms, 1, 2, 3. If the n is 3, you have 1, 2, 3, 4, 4 terms. So that's why it's always R plus 1 terms. Okay, so that's why we call R plus 1 term. R start from 0 all the way to n. N is a power. Okay, M is a power. Or if you use K, that means it will be K from 0 all the way to n. Okay. So over here, like I said just now, so you can use either do it manually. You can also get the answer. But of course, you can also use Pascal's triangle. But if, like I said, if the power is very large, then it'll be very time consuming to use the expansion manually or use the Pascal's triangle. It'll be very time consuming if, say, for example, if n is 100. Okay, so but of course, you can use a binomial theorem for any power. Of course, for smaller power, binomial theorem may not quite worth it because it's a bit time consuming for a smaller power. Like for example, power 2. So using the binomial theorem, this is the n. K start from 0. And then nk. N is 2 over here. So n minus k and then k. So my n is 2. Okay. So it's substitute. So the first term when k is 0, k is 0, 0, 0. This is first term. K is 1, 1, 1. The second term, k is 2, 2. So this is so-called the k. And then the next step is just tie up the maths. Okay. Because 2C0, you can use a calculator to work out. Okay, if not, you can also use the formula to work out. So it's 2. Sorry, it's 1. So the answer for this one is 1. And then 2C1 is 2. 2C2 is 1 as well. Okay. So because this answer you can get it from a calculator if you want. If not, you can use the formula that I showed in my previous video. So k plus 1, this is what they call term k plus 1 term. Okay, so this is so-called the formula for the binomial. I'll just show you one example. If you're asked to find the coefficient of power 8, okay, for this expansion, okay, power 8, how to find? It will be somewhere in between. When you expand it, find the power 8. So, but if you use the binomial theorem, you'll be quicker to get the answer. Okay, so just use the binomial theorem. I do not know which term is going to give me power 8. So I just leave it as k. So n is 10. So k, I do not know which term, I just leave it. Okay, and then the next step, I just tidy up the maths. Okay, take out the 2 to the power n minus k. So k n is 10. So 10 minus k, and then x squared 10 minus k, and then this is x the power minus 1. So, and then the power k. So expand this one using the binomial theorem, you get this. And the next step, just tidy out the maths. Okay, so 2 times 10 minus k will be what? 20 minus 2k. But here there's another minus k. So minus 2k minus k will be minus 3k. Okay, and then from here we can tell this is the power for the x. And then this part is the constant. So the constant part is the coefficient of the x term. So if we are after the x to the power of 8, so I want power 8. So I have already tidied up, put all the x together, the like term together. So x to the power 20 minus 3k. I want this to be 8. So I know when my x to the power 8, so 20 minus 3k is 8. So tidy out the maths. Again, tidy out the maths, we get what? We get k is 4. Okay? So when k is 4, the x is 8. Okay? X 20 minus 3 times 4. So x is 8. So when k is equals to 4, you get the power 8. X to the power 8. So the coefficient, as I mentioned, coefficient is this part. This part is so called the coefficient. Okay. This part is a constant, the coefficient for the x term. So this is x to the power 8. So we need to calculate. We know that k is 4. Just substitute k equals to 4 into here and press a calculator. You get this answer. So this is the coefficient of power x to the power 8.